So this talk might be a little bit unconventional because I don't actually have slides for tonight. My talk is literally going to be live coding with PyTest because I want to show y'all how to really get started with it, what you can do, how to write some different tests, why you should do certain things and why you shouldn't do other things. So I'm going to be coding. I'm going to be opening up Visual Studio as my editor. I like Visual Studio Code as my editor because I think code is fairly lightweight, but still has a lot of the main features you want for an IDE. So I'm also going to be pulling up some web pages here as I talk. So let's talk about what PyTest is. I'm sure most anybody who's been around the Python community for long enough has probably heard of PyTest, or maybe unit test, which is another test framework. PyTest is a test automation framework in Python. It is third party. It's not part of the standard library. But it is, according to the Python Developer Survey, the most popular Python test framework currently out there. I've got the docs page for PyTest open right here. I really like the docs page because it has really good information. And anytime I need to look up something, I come right here and boom, it's really helpful. I also like the first example they have on the page. For somebody who doesn't know much about testing or automation or what PyTest is, the reason why we test our code is for two purposes. We want to verify goodness and identify badness. A lot of people think code or testing code is about finding bugs. That's only half the battle, right? We definitely want to find any defects in the software we develop, but we also want to have a peace of mind to say, okay, everything I just did is good, so I can keep moving forward without worry. If we look at the example here, this is a test case in PyTest. Even though it's only 2 lines, it has everything we need. We've got a function, because in PyTest test cases were these functions. It's prefixed with a test underscore prefix to denote that this is a test case function. And inside my function, I'm making calls. For example, I'm making this increment call to this increment function, which is supposed to do something. And when I make that call, I'm making an assertion to validate goodness or identify badness based on some condition regarding this call. So in this case, my increment function, if I pass in a 3, I'd expect to get out a 4. So 4 = 5, this assertion would be false, and this test case would fail. And all test cases are basically written like this. We do some stuff, and we make assertions to see if it's good or bad. Pardon me. That's what PyTest does in a nutshell. It lets you line up these dominoes of test cases and knock them down altogether. When you have multiple test cases, PyTest will discover them all based on the file name or the function name. It'll execute every single one of them, one after the other. If there's any issues in one, they'll stay localized because it's independent. Each test case is independent. And so a failure in one test case should not affect other test cases. And at the very end, it'll print out this report to explain this is what was good and this is what was bad. So let's write some PyTest test cases together. Here I am at my terminal. I'm going to make a new project. Let's call it Chippy Tests. Okay. You can add test cases to any Python project. You can either create a new project containing a whole bunch of test cases in isolation. You can add them to an existing project that you already have.
And did you mind zooming in a little bit more?
Oh, sure. Let me, oh gosh, one moment. Is the text just a little small?
Yeah, just a little bit.
Okay. Oops. Is this a little bit better? Or do we need more? I can do more.
Can we go a little bit more?
Yeah.
As much as you feel comfortable using.
Yeah. Not a problem. I just have to resize my window here. Oh my gosh. Yeah, wouldn't want to make things invisible. All right, here we go. Big and bad. All right, so where am I?
Thank you.
Okay, cool. So I'm in my new project folder. Now you may be wondering, should I make my own project or should I add them to an existing project? That depends heavily on the type of test cases you want to write. If you are writing unit level test cases, meaning white box tests that'll make direct access calls to the code, such as you're directly testing methods and functions, I would say add those tests in the same project as the code being tested. If, however, you were doing some sort of black box test, maybe you're doing integration tests with REST APIs, or you're doing web UI tests, that's when you might consider having a separate repository. The advantage of having it in the same repository is if it's in version control, it's all version control together. However, sometimes certain tests test multiple things and multiple pieces. And so if you have an application or some sort of backend thing that requires like 3 or 4 different pieces coming together, and each of those pieces has their own repository, that's when you might want to have a separate project or separate repository for those kinds of tests. So just think about your needs. There's no necessary right or wrong answer to it. It's just about what's going to help you in your workflow. So because we're doing this as a standalone example for tonight, I'm going to create my own folder, a new project, and put everything in here. So I'm inside of this, and I'm going to use pipenv for managing my dependencies, just because it's easy. I want to get pipenv install pytest. So take a minute just to get it in there. Pytest is the only dependency you need for pytest out of the box. There are a bunch of pytest plugins publicly available that you can also add that'll be in separate packages. Things like code coverage or BDD or HTML reports. And if we get a chance a little bit later, I might incorporate some of those. So please don't fail me now. There we go. Okay. So if I look inside my project, I've got my pip file, my pip block. I'm also going to create a directory called tests. By convention, all pytest test cases should go into a directory named tests that's under the root directory of your project. That's where pytest by default will go to look up test modules and test case functions. I believe that can be changed, but it's fairly conventional, even in a unit test framework, to have a tests directory. So let me flip over to Visual Studio Code, and let me open up that workspace. Programming. Where are we? I can't even, oh my gosh. There we go, Chippy tests. Oh, it's not gonna let me do that. I have to open as a, my bad. I don't even know my own editor. I'm sorry, folks. This is a fun of live coding, isn't it? Chippy tests. There we go. Okay. All right. So I'll also make sure that this is hopefully big enough. So I have my test cases directory. In here, let's add some basic unit tests just to show how to use pytest. So I'm going to say new file. I'm going to call it test_math.py. And this module.
Do you mind throwing that a little bit bigger as well?
Yep, sure thing. So I want to see some text before I do that. This module contains basic math unit. Oops. So let's see, boom, boom. Whoa, is this okay? Do we need a little bigger?
Can we go a little bigger?
Boom, let's try this.
That's perfect.
Okay, cool.
Thank you.
Yeah, it looks like Duplo blocks on my screen, but that's okay.
And do you also mind, somebody asked to hide that notification for Google on the bottom that says hide?
Oh yeah, whoopsie. Oh gosh, I'm so paying attention.
Thanks so much, Andrew.
You're welcome. Thanks, Joe. Okay, so I'm going to hide the tree for the project for now, just so we have bigger space to see our tests. So let's just write some basic pytest. So def test 1 + 1. So again, I'm going to have a test case function, and it's inside of a test case module inside of the tests directory. When pytest does its discovery, it'll go to the test case directory. It'll look for any modules prefixed with test underscore, and inside these modules, it'll look for all test cases that are test prefixed by, it'll find all functions prefixed with test underscore. So that's how pytest knows where to find its test cases. So if I make a basic assertion, assert 1 + 1, what would we expect this to equal? I expect it to equal 2, right? So again, I'm making a call, having my assertion. If I want to run this, new terminal, see if I can do it in here. That's not going to be too good. I'll just use the external terminal. So in here we have, if I clear the screen, bring it to the top. So we know we have some test cases in our tests directory. From the root of the project, I want to run my pytest command to do the discovery if I want to run the tests. So since I'm in my project root, I have to say pipenv run because I'm using pipenv. To run pytest tests, python-m pytest is the command. I believe you can also run it using just the pytest command. I think that's added to the command line, but I found sometimes that has some weird, funky path issues. Every time I run it with python-m pytest, it seems to work fine for me. So that's what we'll do right now. When we run it, we'll see the pytest banner. It'll show the start of the testing session. In pytest lingo, the session is the entire run of all of your test cases it discovers. It shows my root directory. It shows that through its discovery, it found one test case. It was in this module, and you'll see a green dot here. The green dot means the test was successful. If you had multiple modules, it'll spill it out here. End of the banner, one test passed. It only took 0.03 seconds. Interesting thing, rule of ones, unit tests typically take about a millisecond. Integration tests with service APIs typically take about 1 second. And end-to-end tests with web UI typically take about 1 minute. So unit tests, very quick. So that's the happy path with pytest. Nothing terribly earth-shattering here. Let's make it a little bit more interesting. Let's say I have test 1 plus 2. If I'm going to spill it out just a little bit different this time. I'm going to use some variables. So if I say assert a plus b, which 1.2, or 1 plus 2, we would expect this to be 3. Let's screw it up. Let's deliberately inject a failure here and see what happens. I'll come back to my terminal. Let's run the tests again. It should discover 2 tests now. So here, instead of seeing 1, we see 2, and we see a big red F for failure. Anytime you have a failure, pytest will print out all of the failed test cases with a little bit of introspection and logging. Here we go with the failures. Test 1 plus 2 is the test that failed. We'll see the code for that test case function, which is really nice. You'll see exactly the line upon which it failed. That's this assertion line, assert a plus b equals 99. Now, what's really, really nice about pytest is it does give you a level of introspection. That's why I used variables here. So instead of just saying 1 and 2, I used a and b. Notice here on the introspection line, it substitutes the values that these variables are. So it's saying assert expression 1 plus 2 equals 99. This is really helpful because if all I were to see is a plus b equals 99, if this were a more complicated test, I may not really know what a and b's true values are, and I'd be scratching my head, what's going on? I might even have to do some live debugging to figure that out. But because of the introspection, pytest substitutes those values in directly for me into the output. So I know right away, oh, duh, these are not what I expected, or maybe this wasn't what I expected. Anytime assertions fail, meaning assertions have a false condition here, Python raises an assertion error. Another interesting thing is assert is not necessarily a pytest thing. It is a Python thing. Assert is a command in the Python language. It's a reserved word, so you can use it anywhere. But pytest just uses the basic assert command from the language to make things concise, simple, Pythonic. So anyway, we have that assertion error. We have the test case failure. And then we'll even see it spilled out here. This is just more of a printout explaining what failed. So you can see pytest is really helpful, not just for passing tests, which just kind of blip and then move on, but failing tests, it gives you a lot of rich information just out of the box. You could even use different options to get more stuff. So let's go back and fix this. We know 1 plus 2 should be 3. If we run our test case now that we've cleaned it up, we should see everything passing. Cool. Alrighty. Let's do some more interesting test cases here. So let's try to do a divide by 0. So does anybody know what happens in Python when you try to divide by 0? it should raise a 0 division error as an exception. If I were to just leave this as it is, this will raise that 0 division exception or 0 division error. It will be raised up to the level of the test case being run by pytest. What pytest should do is it should catch that, dunk it as a failure, and then move on to any other tests it might have. I can show that by running pytest again. Oops. So in this case, we see F. We see that there was a 0 division error on this particular command, and that this wasn't an assertion error because there was no assertion done. It was a 0 division error. So this is to note that in pytest, even if you have a rogue exception leak out, pytest, the framework, will still catch it and keep all of your other tests safe. That's what we mean when we say tests are independent. They should not affect other tests. And good test frameworks have built-in features like this to help with that. So you might now be thinking, okay, well, in this case, it's expected to raise a 0 division error. How do we assert that it has done that? You might think, well, maybe I could wrap it in a try except, and then just make sure catch. Try except. Oh gosh, what's happening? Yeah, you could try to do like a try except here. Try except expression, yeah. Oh my gosh, I'm sorry. The fun of live coding, getting confused by your own editor. There we go, that's what I'm looking for. And you could do something like assert true, and this is kind of like, oops. And up here, you could do something like assert false, but this is really, really janky. If we want to cleanly handle exceptions in pytest, pytest offers us something pretty helpful. It offers us a thing called pytest.raises. What I need to do is I'll need to import the pytest module at the top of my test module. And then in here, instead of doing all this kind of wonky stuff, what I want to do is say with pytest raises 0 division error as whatever my exception is. Then I can do the expression that is supposed to trigger whatever this exception is. And so pytest will accept this and say, okay, when I run this, if I get an exception that matches this, cool, I'm good, keep going. If I don't, let's say there's no exception or the exception is of a different type, then dunk a failure and abort and call this test case failed. Furthermore, you can make assertions based on the exception itself, such as the message. I could say a further assertion, not only is the exception thrown, but assert division by 0 is in, the string of the exceptions value. So this is the correct way to handle verifying that exceptions happen in pytest. This will get the job done, but it's not very Pythonic and it's not very pytest-like. So I'll delete that for now. We run this test now. Let's see what happens. Cool. So we're back up to all passing tests. So even though we had a test case, throw an exception internally, pytest had the mechanisms to catch it, verify it was good, and keep going. Alrighty. Let's add one more test case here before we change gears a little bit. There may be times where you want to run a bunch of different input combos on a test case. For example, let's try multiplication. Test multiplication. Let's say I have A equals 2, B equals 3, or A times B equals. Let's do this. Let's say I want to test something. Oops, like this, where I have another operator, I want to test some sort of condition on it. But let's say instead of just using one set of inputs, what if I want to test something like 1 times 1 or 10 times 9 or -3 times 8? You could duplicate this test case, something like this. But we also like the principle of don't repeat yourself, or the dry principle. If we do this, this will create a lot of duplicate code. It will add up tons and tons of lines to our test cases. It's very, very common in test automation that you have a lot of duplicate code because you have a lot of duplicate operations. Duplicate code is code cancer. Why? Because if you copy, paste, and paste, and paste, and paste, you're spreading out these problems all over your code base. Anytime you want to refactor, it's very hard because you have to refactor here, and here, and here, and here, and here. So it's a great challenge when writing good test automation to apply the don't repeat yourself principle. If we want to have multiple combos of inputs, pytest provides a way to do that as well. It's called pytest mark parameterize. What we can do is we can specify a set of parameters to put into this test case procedure, and pytest will essentially crank through all of them. Pytest mark parameterize has 2 main inputs. The first thing we want to do is we want to specify names for arguments to push into the test case function. I'm going to specify A, B, and C. In the test case function signature, we also specify those arguments. Whatever here should basically match what's ever here. What pytest will do is it will inject values for these by name. So I can delete these here from being hard-coded. Second part of the parameterized piece is now we have to provide sets of inputs for these variables. And we provide them as a list. So I'm going to make a list of tuples. So our original case was A equals 2, B equals 3, and C equals 6. I could also have 1, 1, 1. Or let's say 5, 0, 0. And let's say -3, 4, and -12. Each one of these represents an input combination. So in this case, this test case will be run 4 times, 1 for each row. Pytest mark parameterize is really nice because we get to maximize our code. We should also be thinking in terms of equivalence classes for the values we try to push through a test case. For example, some of the equivalence classes I could denote here are just basic positive multiplication, identity, multiply by 0, multiply by a negative number, right? We don't want to have excess combos because that adds to not only our burden of the code to maintain, but also the test execution runtime. But we also, nevertheless, we want to make sure that we have the interesting cases, the edge cases, that we cover all of our main bases. So that's why this is a really, really helpful thing. So if I run the tests now, it should be 7 total. And everything is still passing. Cool. So, pardon me. These are just some basic unit tests, right? They're not even calling functions. They're just calling basic Python expressions. Let's do something a little more interesting. I wanted to show these examples just to show the basic mechanics of how the PyTest framework works. Let's do just a few more unit tests, but instead let's use a class to test. So I'm going to create a new package, actually. I'm going to call it, top level. I'm going to call it stuff. I'm going to have a package full of stuff. And here I'm going to make a dunder init. And I'm going to also add a Python module called accumulator. What I want to do is I just want to add a very, very basic class that I can have some methods to do some testing. So if I have an accumulator class, Oops. Let's add a dunder init. And let's say I want this to have a count. And let's say I want the count to default to 0, and I'm going to initialize the count. And I'm going to add a method called def add, which we're going to add values to that accumulator. Nothing terribly fancy here. So all this class does is it stores some sort of count. I can initialize that count to be whatever value I want, and I can add however many more things I want to my accumulated value. I put it in a package called stuff so I can reference it elsewhere in my project. And so now let's make some tests, some unit tests for this accumulator. I'm going to create a separate Python module, test accumulator.py. And in here, I need to say, I want to import my accumulator class if I want to do testing on it. So I say from stuff.accumulator import accumulator. Cool. Notice how I didn't put that package underneath my tests package. The reason why is because if this is what my quote unquote product code is, this is the thing under the test directory, then you should still be able to deploy to production and be okay. So let's write some unit tests for the accumulator. Now, if I wanted to say something like def test accumulator init with, let's say I wanted to test what that initial value is for my accumulator. So I could say something like A equals accumulator. That will initialize my class. And then I could say assert, assert a.count should be what? Well, we expected that to be 0 based on default values. I could also run another test. Let's say def test accumulator add 1. And again, I'd say, okay, initialize my accumulator. And then say a.add. We'll just stick with the default. And then now we would expect a.count to equal 1 because we've added 1 to it. And I could also have one more interesting thing, test accumulator add 3. Again, a accumulator initialize, oh my God, I'm sorry, I'm used to C#. That's what the semicolons are there. A.add 3. I could say assert a.count would now equal 3. We could do tons more testing here, but for the sake of example, I think this is sufficient to show here's ways in which we could test a class, not just a set of expressions or even a function call, but actually testing a class. Let's run these tests and see what happens now with our pytest banner. So we see now we're up to 10 tests total. We also see that pytest separates by module the test cases that we've run. We see 3 from the accumulator class and we see 7 from the math class. That's cool, awesome. What if I only wanted to run tests for the accumulator and not the math tests? We can do that using pytest's command line options. If I don't specify a path, pytest will find everything from the current directory down. But I could specify test accumulator. And by providing a path to the module, here we can see on a second run, pytest only discovered and ran the tests from that module. So here, only 3 ran and 3 tests passed. That may be advantageous if you are doing reruns of some tests, like you found something failed, and you don't want to rerun the entire suite. You just kind of want to pinprick and laser point to get to where the failure was. You can use paths. You can also use tags. You can use, I think, even directly down to the test case name, though that syntax can get a little bit hairy. So Let's come back here because there's actually room for improvement in these test cases we wrote. If you remember what I said just a few moments ago, I said we like to apply the don't repeat yourself principle. However, we've repeated ourselves. The object initialization for the accumulator is essentially duplicate code. For this trivial example, it's not that big of a deal because, I mean, it's small. But in practice, what you'll most likely find is that when you have to construct objects for testing, there's a lot of stuff you might have to put in here. And so there might also be multiple steps in order to set up or create or initialize a particular object that you would have to do over and over again. PyTest provides a better way of doing that. Anytime you want to have shared setup or cleanup, we want to use what we call a PyTest fixture. If you're familiar with other test case frameworks like unit test or any of the X units like JUnit or NUnit and other languages, you'll know that you have setup and cleanup methods inside of your test case classes. Since PyTest doesn't have test case classes, it has test functions, we need separate functions in order to handle our setup and cleanup. And that's where fixtures come in to help us. So if I want to use fixtures, I have to import the PyTest module again. And what I can do is I can say, I want to create a function that will do my initialization of my accumulator. So let's call it accum for now. We want to decorate this function with pytest.fixture. Oh my gosh, there we go. pytest.fixture. By putting this decorator on, we're saying, hey, this is a special function for PyTest. What we want the fixture to do is create this object right here. We want to create a new accumulator and return it for use. So I can say return accumulator. And for the case of this example, we can just leave it as the default input. So now what we can do is instead of calling this initialization redundantly, I can have each test case called a fixture. To call a fixture, what I do is in my test case function, I declare the fixture by name in the argument list. Kind of like how we did for injecting our parameters in the math test. Anytime PyTest comes to a test case function, it discovers and it sees, oh, I have an argument name. It'll look to see if there's an available fixture of the same name. If there is, what PyTest does is says, aha, I have a fixture. Before this test case runs, I'm going to call this fixture. And whatever the fixture returns, I'm going to inject into the function call here. Not only is this a setup routine, this is dependency injection. It's really cool. And so I no longer need this call here. Instead, accum now is an object that references the returned value from the fixture of the same name. So I can do this. Let's refactor our code. Boom. Sweet. So we have a fixture now, and we've refactored our tests to use that fixture. And I can prove this works by rerunning. I run the accumulator test again, and it all still passes. Cool. Fixtures are lit. I'm not going to lie. Fixtures make PyTest one of the best test frameworks in any language, in my opinion. The problem with XUnit style frameworks is that when you have your setup and cleanup methods locked inside of test case classes, that means that they can't be used outside those test case classes. And you also potentially enforce a nasty inheritance chain. In PyTest with fixtures, these things are very reusable. I can separate the concern of the test case from the test setup. I could have multiple fixtures called by individual test cases. I could have fixtures called by some and not called by others. If I wanted to have a different kind of accumulator, I could make accumulator 2. And let's say that initializes to a count of 2. And I could use that in other tests. Fixtures are very, very shareable, right? You can use them outside this module. So let's say I wanted to use them outside the module. What I want to do is I want to create a different module under my tests directory. It's called conftest.py. Conftest.py is a special pytest module. The name matters. I didn't just pull this out of my butt. This is an official pytest thing. Anything you put in a conftest.py module will be shared by other modules and accessible by other modules using pytest within the same level of the hierarchy, the same directory and any subdirectories from here. So what I could do is I could wholesale move this out and drop it into here. Of course, I'll need my import statements. But here, now I've had my fixture function in an entirely separate module from the test accumulator function. Sorry, I have the fixture function in a separate module from the test accumulator module. But the tests are still going to have that referenced by name. It'll still work. Oops. Yeah. So if you want to share test fixtures between multiple test cases, best practice is put them in a module or put them in the conftest.py module. Alrighty. Also, if you want to learn more about some advanced fixture stuff, highly recommend the pytest docs. You can do things like setting scope. You only want a fixture to run one time for the entire test suite versus for each test case. You can set a scope of session. Usually as a best practice by default, you want your fixtures to run per test case as they would be here. But just there's all sorts of fun stuff you can do. They're even out of the box fixtures, right? Things like setting up temporary directories, accessing test requests. It's pretty rich. Cool. So let's come back and look at running our tests again. We know at this point we have, oops, sorry about that. We have 10 different test cases, and they're all unit test level. I run them again, show that they all still work together. You may be wondering, what are some other interesting things I can do? Because this little banner is very helpful and nice, but it's not like a ton of information, right? What if I wanted to get something like code coverage out of this? PyTest has a module for that. Let me clear it, bring it to the top. If I want to do code coverage of PyTest, all I have to do is install the PyTest cov module. Underneath the covers, this will use coverage.py. So here, if I'm installing it, just give it just a minute here. There we go. Okay, cool. Oops. All right. So if we want to use code coverage, what we can say is when we invoke our test command to run, we use the -- cov option. Oh, did I screw that up? Yep, there we go. Whoa, okay, that was huge. Okay, so yes, if you want to run with code coverage, you run with the -- cov option. It'll still show the same banner as it did before, but then it'll show you all the statistics about how code coverage was handled. Now, it's a little bit hard to see. The reason why this is so spilled out is because it actually looked for code coverage in my virtual environments. So that's no bueno. Let me try that again. If I give it a path, if I explicitly tell it to look in my tests path, let's try it again. That should be a little bit cleaner. That's much better. Okay. Live coding, you surprise yourself sometimes. So if you specify the path, it'll only do code coverage within that path. I really should have done code coverage for the stuff package. So let's try that again. There we go. That's a little better. So if we look at the banner, as again, I said, it's all the same, but it'll also add this coverage piece to your output. And it'll show all the files in the path that you specified. So in this case, since I gave it the stuff path, we're looking for code coverage and stuff accumulator.py. And we can see the percentage of statements that are covered and the number of statements that we're missing. And it tallies it up for you here. I believe there's some slightly more advanced options with code coverage than just what you see here. But you can play around with it, look up the docs and such. And it adds on to pytest as a plugin. Another plugin you may be interested in would be Clear pytest HTML. If you want pretty HTML reports instead of just the pytest banners that print out, you can use the pytest HTML package. Boom, boom. Okay, so if we wanted to print an HTML report, we could say with our pytest command, --HTML, and give it a file name. So now when we run, you'll see added to the banner, generated HTML file, user, and okay, that's me, pytest report. So it should be in this directory. If I check this out, you can see it's all HTML, but we don't want to see it like that. We can open it up in Chrome or Firefox or Safari, and we should see something nice and pretty. Typically, this is the kind of thing you'd want to show in CI or send to your manager or something. But you can see it's just a more visual way to see how everything spills out. So that's really cool. Both of those things I just showed you are what we call pytest plugins. Pytest plugins. pytest has a myriad of plugins. Another reason why I love pytest is because it has this plugin framework, right? You can extend pytest to do almost anything you want. The basics are there, and you can just add on, whether that's special kinds of checks or integrations with other frameworks, or even new kinds of ways to write tests. So pytest-cov and pytest-html are very common ones. You can go to the pytest docs page. They have plugins for things like Django. Xdist is used for parallel testing. Pytest BDD is to write Gherkin-style tests. I love BDD. You can check for PEP8. I mean, it's all there. And you can even write your own plugins. It's not like you have to be a wizard. Technically, anything that you put into the conftest.py module is de facto a plugin. But so technically, this fixture is a plugin. But usually when we say plugin, we typically mean a package of stuff that adds to the pytest framework. So I could speak worlds more about pytest. There's a lot in this framework. I hope what I've shown today in terms of unit tests is very valuable. If you want to learn more about pytest, a few things I can recommend. First of all, like I said, the doc page. There are a couple books I can recommend. Python Testing PyTest by Brian Ocken. This book is wonderful. I know Brian, I've read the book. Very, very helpful. He shows how to use all the different facets of the pytest framework. Another book, Getting Started with PyTest, or PyTest, what is it called? PyTest Quick Start Guide. Here we go. PyTest Quick Start Guide by Bruno Oliveira. Bruno was one of the PyTest core developers. He wrote a very, very helpful getting started guide with PyTest. This one I think is a little bit better for those who are kind of new to testing as well as new to PyTest. And so it's much more like a tutorial setup where it's like you read a lot of information and you kind of iterate as you go, which is, I mean, both books are really good. If you want to learn how to do something more than unit testing, if you want to do, say, web UI testing, today, Test Automation University just released a new course that I developed called Selenium Webdriver with Python. This will show you how to interact with a web browser using Selenium Webdriver, actually sending clicks and sending text, and using Python with pytest to automate tests around that. So definitely give this tutorial a check if you want to learn how to do something more than unit tests. You could also do things like REST API tests using the request module or Tavern maybe. But I mean, pytest is not just a unit test framework. It is also an integration test framework, is also an end-to-end test framework. It is a general purpose test automation framework. So yeah, I hope that was really helpful. If you want to follow me, you can follow me on Twitter at Automation Panda. You can also check out my blog at automationpanda.com. I've got a lot of stuff on testing and Python, and good stuff in general.
Awesome. Thanks so much, Andy. Can people in the chat please give Andy a round of applause? That was very, very useful information. So we do have some questions. So if you do have questions in those of us that are watching, please ask them in the chat. We will queue them up and the speaker will get to them. So actually, I'm going to ask my question first because I think it's a little bit easier this way. So say you work in an organization that is just starting to implement testing and you're trying to convince others to take up the testing mantle. How do you go about doing that? What's the business value of testing?
Oh, man. So that's a great challenge because not everyone sees the value. Well, the value I always pitch for testing is, like I said when I opened, it's identifying badness as well as verifying goodness, right? The idea that if you write a test, this is an artifact of your software development process. So you should treat it well. You shouldn't treat it like crap. But it's there to protect you. It's there to be your insurance policy. It's there to be a mitigation, or it's there to mitigate risk. And so when you write a test, what you're saying is, I think it should work this way. Not I think, I know it should work this way. This is kind of like almost like requirement level. This is what it has to be. And so when you take that tax of time as you go and build up your test suite, the further out you go with it, the more tests you have, the more protection you have. I think people's eyes really don't open at first. They kind of see it as, oh, well, this is like an extra activity. It's a tax on my time. I'm not sure I'm seeing value. But if you stick with it, you'll eventually hit a point of critical mass where your tests inevitably start catching things. And then people have bing bong, oh, light bulb, like, got it. Oh, this really is valuable because I made a change, I ran the tests, and it caught a failure before I deployed it, right? So that's, I think, where you can have the selling point with trying to convince others that tests are really valuable.
Yeah, that's a fantastic answer. We actually have some questions from our audience. So some folks have been starting to implement testing at work. Some of the people at their job are picking up pytest. Others have decided on unit test. Can you go over some of the pros and cons of going through unit test or the pytest framework?
Absolutely. I have very strong opinions on this. So advantages of unit test. Unit test is part of the Python standard library. You don't need to pip install to get it. It's there out of the box. It follows the XUnit style framework. So if you have people coming from another language like Java using JUnit or C# using NUnit or any language that has an XUnit style framework, they're going to intuitively know how to use unit test off the shelf. So you don't need to do a whole lot of retraining. They say, oh, so I have a test class. Inside of there, I have methods that each represent a test case, and I have set up and cleanup methods that do. I know this, right? There's a sense of familiarity there. The cons of unit test are that, first of all, you're locked into that class structure. In my opinion, I don't think a class is necessarily the best way to encapsulate the entity of a test case. I think the XUnit style way of encapsulating test cases like that is simply an artifact of the time in the 70s and 80s where object-oriented programming was the shiny new thing and everything got shoehorned into the structure of a class. Hot take it for what it is. I'm not saying that's right or wrong. I'm saying that's my opinion on my perspective of why XUnit style test cases are the way they are. And really, PyTest is the only one that's doing something a little bit different in this vein, where a test case is truly a function, more functional-esque type programming where functions are first-order values. We try to keep things simple. And so the advantage of PyTest, I think, in that case, is that I think functions are simpler than classes. I don't think classes are necessarily complicated or too hard for people, but I think functions are simply simpler. Also, with PyTest, you get those fixtures, which make setup and cleanup much, much more reusable. So you're not limiting your setup and cleanup to be inside of one particular test case class, then hum and ha, oh, well, I need it over here. Well, do I need to make like some sort of new module to have all this setup cleanup logic? Right. Fixture, boom, done. Put it in conftest.py, share it everywhere. And then you can use dependency injection with that fixture. And you have controls over the scope, and you can have some test cases using multiple fixtures, some test cases not using fixtures. And another thing I didn't share is that fixtures are not only setup but cleanup. We saw a fixture with a return statement. If you have a fixture with a yield statement, it becomes a generator. Iteration 1 is the setup, iteration 2 is the cleanup. So you have setup and cleanup paired together, which is typically more sensible for what you want to do. Third reason for why I think PyTest is better than unit test, those plugins. PyTest is easily extendable. Unit test doesn't have that. And so like you can put things in unit test and you can use it. It's a great framework. It's simple, it's easy outside of the box. But PyTest just gives you so much more firepower. So with all that to say, I think PyTest is categorically better than unit test. Unless I were forced to otherwise, I would always use PyTest. I would not have a case for using unit test, unless for some reason I'm not allowed to pip install PyTest.
Yeah, it's I've always found that the inheritance hierarchy that unit tests are just like forces people to take on, it makes your tests really hard to follow. And then you have test fixtures that are changing things in tests that don't have anything to do with those fixtures. Yeah, I think we're all there. So yeah, PyTest has changed my life in so many ways. Fixtures are my favorite thing.
Yes.
We actually had a question from Jay about asynchronous code testing. Do you have any books or recommendations on doing things like that?
Oh gosh, yeah, the async thing has taken Python by storm. In fact, I've been to so many Python conferences, they're all blurring together. I know there are several very good conference talks on testing with async. I can't begin to remember where and what conference. Past 2 years, if you Google Python, PyTest, async, you'll find something.
I think PyCascades just had one back in February. I'll post a link. Check our YouTube comments down below after this video to find out where to find that talk.
Yeah, and there is a PyTest async AIO plugin. So if you just Google PyTest-async IO, you'll find it. It's part of the PyTest dev project in GitHub, so it's like officially sanctioned and all that by the project. That's probably the best place to go to kind of learn on your own, I would guess.
Awesome. We got one more question. Other than PyTest-Cov, are there any other plugins you use to determine how good your tests are in terms of quality?
Me personally, no, but I am positive there's something good out there.
Cool. Awesome. So I just have one last question. Do you have any action items, calls to action for our community?
Gosh, yes. Treat each other well, especially during COVID times, but also during non-COVID times. Get plugged into your local community as well as your international community. Get part of local meetups like this, go to conferences, get to know each other, and just be awesome. And write more tests. Write more tests.
Write more tests. Words to live by. Well, thanks so much, Andy, for joining us. I'm really glad you get to experience what Chippy's all about.
Thanks for inviting me. It's been a blast.